Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Ahmad Shami bin Ilyas, MKA 191011. So today I will share about the breakpoint chlorination curve. First of all, I would like to share some basic fundamental to ease our understanding on chlorination breakpoint, which are the types of chlorine and also the type of ammonia. For types of chlorine, first is the free chlorine, where free chlorine is the amount of chlorine available to disinfect contaminants such as chlorine gases, hypochlorous acid, and also hypochlorite ion. And it is also known as active chlorine. Next is combined chlorine, where it is the amount of chlorine which is not available to disinfect contaminants. It combines with organic and inorganic nitrogen-containing compounds, and it is also known as chloramines. The last one is total chlorine, where total chlorine is a combination of both free chlorine and also combined chlorine. For types of ammonia, first is the free ammonia, where it is the amount of ammonia which has yet to react with chlorine. Next is total ammonia, where it is the summation of unionized ammonia and also ionized ammonia, or also known as ammonium. Now we move to the explanation on the breakpoint chlorination curve, where it is the reaction and relationship when different amount of chlorine which react with ammonia to the total residual chlorine. We can divide the reaction into 4 zones, zone A, B, C, and D. We have a look at zone A first. Initially, when chlorine is added to water, it will first react to and utilized by oxidation agent or reducing agent such as iron, manganese, sulfate, and nitrate. That's why in zone A, there is no uptrend on residual chlorine, and the total ammonia remains at the same amount, where total ammonia equals to free ammonia. Next, we move to zone B. When the amount of chlorine is continuously added, it will react with ammonia and produce monochloramine, which is a combined chlorine. So what happened are the amount of monochloramine will increase as the amount of free chlorine decrease after it react with chlorine. However, the amount of total ammonia remains the same. The reaction in this zone will end when the total ammonia equals to the amount of monochloramine and when there is no more free ammonia. The reaction at this zone occurs when the ratio of chlorine to ammonia is 5:1 or less. We move to the next zone, zone C. As explained previously, this zone starts when there are 0 free ammonia and when the total ammonia equals to monochloramine. So as the amount of chlorine keep on increasing, monochloramine will react with it and produces dichloramine. What happens are the amount of monochloramine decreases as it changes to dichloramine until it is absent. Noted together that the amount of dichloramine also reduces until a certain level due to oxidation or decomposition. The reaction at this zone occurs when the ratio of chlorine to ammonia is between 5 and 10:1. Next, we move to the final zone, zone D, where it starts when there is 0 monochloramine. When the amount of chlorine keep on increasing, dichloramine will react with it and produces trichloramine or nitrogen trichloride. However, the production of trichloramines are slow. Hence, the additional chlorine added will be in the form of free chlorine, where it is ready to be active for disinfection. Highlighted here that at the point where dichloramine is absent and trichloramine started to produce is the chlorination breakpoint. At this point, all ammonia has been oxidized into nitrogen gases, nitrate, and trichloramine. The reaction at this zone occurs when the ratio of chlorine to ammonia is 10:1 and above. Before I end my presentation, I would like to add and re-highlight some important facts related to our discussion, which are, number one, Ammonia reacts with chlorine to form mono, di, and trichloramine. Number 2, the formation of all three chloramines depends on pH and also the ratio of chlorine to ammonia. Number 3, all three chloramines are measured as part of total chlorine. Number 4, all three chloramines are also a disinfectant, but they are weak. Number 5, di and trichlorine, which produces at zone B and C, will cause taste and odor issue. Number 6, summation of all three chloramines is combined chlorine. And the last one, free chlorine, can be in the form of hypochlorite or hypochlorous acid. Thank you. Assalamualaikum warahmatullahi wabarakatuh.